do is we're going to talk about solving problems using trigonometry. Now, I need you to think about our Trig Toolbox. When we talk about our Trig Toolbox, we're talking about things that deal with triangles. Trig really stands for triangles. So imagine if I have this triangle with angle theta, or we could write it as A, B, C. Now, when we're doing these, working with this, we need to label all the sides as hypotenuse, opposite, and big adjacent. Okay? Now, when we're talking about the right angle trigonometry, we're talking about things like SO, CA, TOA. And we're talking about the basic trig ratio. So if I was using sine of theta was always going to be the opposite over the hypotenuse. Cosine of theta, based on SOHCAHTOA, is going to be the adjacent over the hypotenuse. And tangent of theta is going to equal opposite over adjacent. Now, when we talk about non-right angle trigonometry, what we're talking about is stuff that deals with acute triangles for now. Later on, when you're in your next grade, you're going to be working with, instead of right angle trig and non-right angle trig, what we're going to be doing is we're literally going to be taking a look at triangles that aren't necessarily acute. But for now, for our non-right angle trigonometry, we have this thing called the sine law. And the sine law is equal to A over sine A, B over sine B, equaling C over sine C. Now that type of calculation, we use 2 of the 3 to solve. Right? And we always talked about our sine sausages, but this form of the sine law is used for just the sides, finding the sides. It just makes it easier to find. And now, the corollary of this would be for angles. If we took a look at angles, what we're going to do is we're going to start off with sine of A over A equals sine of B over B equals sine of C over C. So when we're finding our angles, we use the sine of A over A. We start with sines on the top. Now, let's talk about cosine law. Now, cosine law basically shows you a pattern. I call this the elbow law, or I could also call this Pythagorean theorem based on steroids. Now, the basic pattern is, if I have a triangle, like so, with an angle between it, that means I can find this green side over here. So if I know these two numbers, say 15 and 12, and angle theta was, say, 35 degrees, I could easily calculate this side. Let's call it, this angle, let's call it x, and this is little x. Now, so basically what it's saying is, if I have this angle x, also known as c in this equation, if I know the sides around the interior angle, I can find the opposite side x. And in this case, it's c, the angle c, which is surrounded by A and B, based on this equation. Now, that is the cosine law for a side. Now, if we were looking at the cosine law for angles, we get cosine of C by solving it is this: A squared plus B squared minus C squared divided by 2AB. Now, I showed you how to use cosine law for angles and sides. Maybe you can't remember how to use this equation here. So maybe you go and substitute all your information into the first equation in order to find cosine of C and using regular BEDMAS. Now, let's move on. Now, this problem here is talking about a section of bridges. Now, this entire section of bridges is going to be created, but what we want is just the length of the trusses to build the highlighted portion of the bridge. Now, I could force you, if I wanted to calculate all of the amount of material needed to create the entire bridge. Now, the first thing that we have to do for a problem like this is you're going to take the time, and you should label all of the corners of your important triangles there. Now, you'll notice that we have 3 different triangles. Now, because we have 3 different triangles and the 3 triangles depend on each other, it's important for you to split the triangles up. So I'm going to take a look at the first triangle on the left. We're going to call this the triangle ABC. We're going to go and work on this triangle here. Now that I'm working on that triangle, what we're going to do is we're going to isolate that triangle when we're doing our calculations. So we start with our triangle ABC. And you'll notice that the bottom portion of the triangle is 6.2 meters, and its angle for A is 37 degrees. Now, based on that, we need to find, if we need to find all of the length of all of the trusses based on our triangle, we're going to have to find C and A of our triangle. So the first triangle that we're going to use, the first part of the triangle we're going to use is we're going to go and find this part, A. Now, because we're finding A, what we're going to do is we're immediately going to go and label the sides as, well, this is the opposite. This is the adjacent. No, this is not the adjacent. This part is the hypotenuse. And then this is the adjacent side. Now, based on that information, we've got sine of theta is O over H. Now that allows us, when we substitute, we have sine of 37 is equal to A over 6.2. Bringing 6.2 the other side, because it's division, it becomes multiplication, so we end up with this equation for A. Solving for A, you end up with 3.7 meters is A, because we said we needed to round this to the nearest tenth of a meter. So now that is A, so it is 3.7. So now that's also 3.7, and that bit's also 3.7. Hey, wait a second. That triangle is an equilateral triangle for BCD. So that's from here to there. Perfect. So what we're going to do right away is we're going to label this. We're going to make sure that we know that this angle here is 60 degrees. And the rest of the angle in our triangle is also 60 degrees. So now, for the last side, C, we're going to have to use cosine theta because we have an adjacent and a hypotenuse. Now, I would say for you to always use the referenced information directly from the triangle. Don't just go and start using the side that you just calculated, because sometimes you may have made a mistake. Try to base your calculations based on what you were given originally. So now we're using cosine of theta. So when we calculate cosine of theta is C over 6.2. Substituting in, we end up with this, which means that we get C being 5.0 meters when we finish our calculation. Now, the last thing that we have to do is we have to start thinking about our angles. So if I take a look at this side here, that angle, you'll notice that we have a 90 degrees in this triangle. We also have 37. So in order to calculate this, all we're going to do is subtract to find C. So we're going to take those two angles, subtract it from 180, and we're going to get the following. We end up with C equaling this value here. of 53 degrees. So I'm just going to write that in. Now, the last triangle that we have here, CDE, is an interesting triangle. We have one of the sides here identified as 3.7 meters. Now, we can't really do anything with this unless we have an angle to work with. Now, more specifically, we're going to have this angle. Angle DCE. Now, angle DCE, if I go and extend the line all the way from here across, that's 180 degrees. But we know that we have 53 degrees and 60 degrees here, which means that we can find this angle by subtracting 180 from these two to find this angle here. So now let's do some calculations. If I take a look at the triangle that we have here, it's D, C, and I do believe it's E here. You'll notice that we could find a sine sausage here, right? And the only way we could find that sine sausage is finding this last little bit here for angle C. If I take a look at angle C, based on what we have there, we're literally going to use 180 minus 53 degrees minus 60 degrees to find our angle of 67 degrees right where angle DCE is. Now, because of that, we can start to use the sine law because we know that this is 3.7 based on our triangle, right? And so if this is 60 degrees and these two sides are equal, that means this is also 67 degrees, which means our final angle is 46 degrees. So now we have a sine sausage. Because of that, we can set up this ratio. C over sine C is equal to E over sine E. Substituting in, we end up with this. Multiplying by sine of 67 to both sides, we end up with this equation, which gives us 4.7 for our total number of meters for our truss. Now, I'm just going to go back up here and I'm going to quickly make sure everything is labeled. And so the last thing that we have to do is, because we need to know the total amount of material needed for that truss, all we're going to do is we're going to just add up all that information. So the total sides are going to add up to 31.7 meters. So now, let's move on to our next topic of the day. So when you look at this problem, it says find the height of the cliff to the nearest meter. Now, the reason why it looks like this, it looks like two triangles kind of situated beside each other, is because we're trying to create a three-dimensional shape. So imagine that triangle BCD is actually flat with the ocean, right? And the spot where this little guy is sitting in the ocean creates a 62-degree angle from here to the cliff. And then from the ship to that same spot just below the top of the cliff forms a 50-degree angle with that ship. Now, notice all of those things are kind of sitting flat in the ocean, right? And you know that something that's vertical and something that is flat on the ocean or horizontal will form a 90-degree angle. So any triangle that would have touched this triangle directly above would form a 90-degree angle. So now, when we think about this, we have to think of the base triangle, DBC, to look something like this. Now, you'll notice that that bottom triangle is flat, and it's almost as if it's like sitting on a table. And that other triangle is kind of like a set square that's pointing straight up into the sky. So now what we're going to do is we need to find this part here, CB, I mean. And CB is the most important thing between those two triangles because it will allow us to find the height that exists between A and B. Now, in order to do that, we're literally going to have to make sure that everything from that base triangle is on that triangle. So we got the interior angle for B, and we got the side. So now this allows me to use a sine sausage again. Oh my goodness, look at this. We have matching angles and matching sides, and all we need is this side here because we are looking for the side length of CB. So let us do that. Now remember that we used to call that A. So now the ratio that we're going to use for our sine sausage is this. Sine of D, oh that's a D, not an A, I apologize, over D is equal to sine of B over sine of B. So what we're going to do is we just substitute accordingly, manipulate our equation, and we end up with this final answer here. B is 132 meters. You can pause the video here and continue in a sec. And next, once we've got that side, we could literally go back up to our triangle and write 132 meters for the base of our new triangle. So once we've done that, we can go and draw a side view of what's happening on the cliff. So we have 132 meters, and its angle is 33 degrees for angle C. So I'm actually going to label X as the unknown so that it just saves me some time. This is the opposite angle. This is the adjacent. Side and adjacent side. Let's use tangent to find our angle, our side. So we end up with tan of 33 is equal to X over 132, which means this is the case, which means X is 86 is the height of the cliff. Therefore, the height of the cliff is 86 meters. Now, here are the key concepts for trigonometry problems. You need to make sure that you have to start by creating triangles based on the subsets of triangles that are in your diagram. And you'll notice like we did that here, and we also did that for this equation. A, B, C, and D, right? And E. Now, the last stage of the work that you have to do is you take a moment by labeling the sides or the angles of the triangle. And then you have to find the side that is most important for your triangle and then solve for the rest of your solution. That is it. Key idea. Draw your triangles. Label all the sides or angles that are going to be important, and then find the side that is shared between the two triangles. You'll see several problems like this in your homework for this week. So, take a moment and go over the sheet that I gave you. Make sure you have this written down, and then I want you to do that homework. You have a day and a half to complete it.